which is, as we'll talk about to a certain extent, is a difficult or not impossible task at this point, but hey, get used to it, the visual the asset when you get out in the real world. And that's how to create a requirements document, which is what's due Saturday. Your first, and I will stress quite strongly, this is your first draft. This, even more than your org chart, this is something that you should be updating weekly. And I say that now because what you'll find out in industry is they'll do a requirements document that will never go back and revisit it. And that can create great headaches for you. A well-run IT group will have all the requirements under change control, and it will be periodically reviewed to see which requirements are being deferred, which are being eliminated, and fight great battles for any new one to be added. Yes?
Would you recommend putting it like an actual version control system like Git or Subversion or whatever?
Actually, what it's usually done with is there are any sort of bug databases that are out there, both commercial and open source. And what you'll find organizations do is you'll have this continuum. It's basically bugs all the way up through features, because really they're the same thing when you think about it. A bug is something you don't want in the program. A feature is something you do want, but the issues of severity, criticality, estimates as far as work to either fix it or implement it and so on are all the same. Again, in a professional organization, you will have an actual change control board, and we'll talk about this in a future lecture, that will regularly review all the open defects and or feature requests and basically say, yes, we're going to fix this one for the next build, or we're going to add this feature for the next build.
So for like longer running projects like that, would you recommend like having like an initial like MVP, like a specification, and just like having a feature pool?
No, well, you're going to have a requirements document like this that's going to be there, and then if you have features that you hope to add, yes, you could put those into the database, the defect/feature database, and use that to track priority and estimates on it.
Okay.
So the challenges of writing requirements, because here, for many, many years, the goal was we're going to do a requirements document, we're going to have it complete before we start coding, and we'll have a requirements traceability matrix so that when I'm working on a piece of code, I can trace back and say, when this code is done and does this, it fulfills this requirement out of it. That's from a mathematical point of view, that sounds wonderful. From the reality, it just doesn't work. Well, it's not even just a waterfall. The fact is that requirements explode as soon as you start showing anything to users. Or as soon as you start doing anything to actually implement it. So you're almost always writing requirements before you know what you want to build. I mean, some of you have said that in your brief reviews this morning. It's kind of like, yeah, we have these pools of people, and as we investigate this, we're going to have a better idea of what we're going to need to build, what we want to build, what we're going to add in. You're often, as per Armour last week, writing them before you know if you can build it. Not all programming problems can be solved, and at least not within whatever constraints you have. And there is often a lure of technology. As I mentioned, I did a computer game 33 years ago for the Apple II called Sundog Frozen Legacy. It's in Wikipedia if you want to look it up. In the original Apple II version, your character was a little round dot moving around inside the outline of a ship, or a little dot moving between a top-down outline of buildings on streets and so on and so forth. I just finished over the weekend replaying Tomb Raider 2013, which isn't even state-of-the-art now. And I'm watching individual strands of hair. I mean, it is hard for you youngsters to grasp just what has happened in terms of graphics and physics engines over the past 40 years. And the part of the problem, and the fact, again, Sundog ran in 64K of memory. My laptop, I was playing Tomb Raider On has 16 gigabytes of memory. The problem is that often because we suddenly have lots of memory, because we suddenly have lots of disk space, because we have high-end graphics cards, like we can do everything or anything. And it's very easy to bite off even more than you can chew, given the environment. Another problem with requirements, the wrong people are often writing them. You tend to have three groups: managers, engineers, and marketers. Managers may have a hard time understanding what's actually technically feasible within the desired time frame. And or they may have business drivers. This is a classic: we need to ship this by start of fourth quarter of this year in order to catch, say, the Christmas market. And developers saying, no, you don't understand. We can't get it done by then. Well, you'll have to get it done and we'll fire you. Back at Pages during the year that we were late shipping Pages, there was a point at which the CEO and CFO were trying to sort of line up some of these, well, here's the carrot and here's the stick. You know, if we ship by such and such a date, this is the bonuses that we'll all get, and if they don't, this is what's going to happen to all of them. And I had one of the senior engineers stop me in the hallway, having heard rumors of what they're talking about, and say, don't they realize you're dealing with grown-ups? I said, we've all been working our butts off for 3 years here. It's not like a sudden offer of a trip to Hawaii is somehow going to make us work any differently than we have been working all this time. Engineers, we are admittedly sometimes more interested in building something cool or new or bleeding edge or whatever than what the customers actually will pay for. And sometimes what we think is a nifty feature the customers are totally uninterested in, or vice versa. Pages software, desktop publishing, that I was chief architect for. Type design controls. The basically guarantee was that any document you lay out will automatically adhere to good design principles. And the two founders were a world-class typographer, Mike Parker, and a national level graphic designer, Vic Spindler. You know what our number one request was when we shipped it? They wanted WordPerfect key bindings. It's kind of, well, you know, this is drag and drop, this is state of the art, this is all this. And our 1.1 version had WordPerfect key bindings. This led to an important realization that you will discover beta test users do not necessarily have the same priorities as your actual customer base. In other words, if you're doing a limited private beta test release, you're likely to get early adopters who are jazzed by the cool features you're putting in. When you're actually shipping your product to a mass market, you'll get people with completely different priorities. And of course, the classic marketers who want the impossible. You know, I have had on occasion shouting matches with marketing types who have gone to customers and said, yeah, we can implement this feature, then come back to tell me, and it's like, no, we can't. Literally, we cannot implement that feature, at least not any time frame you're talking about. As noted, customers usually don't know what they want until they see something working. This is a big factor behind extreme programming, the Agile method. Just get customers involved early, which is important. I fully agree with that. But that's like the WordPerfect key bindings. I mean, we spent 3.5 years doing all this state-of-the-art and drag and drop and everything and design. And people wanted. We also, by the way, besides putting in WordPerfect key bindings, we put in Emacs key bindings as well. We had that requested. Kind of like, oh, okay, whatever. No, it's just the people. You know, we had customers there, and some of them. This was also an important lesson for me to learn, and we'll talk about this repeatedly through the class. People hate change. People hate change. How many of you are iOS users? How did you feel when iOS 11 introduced this new keyboard?
I don't want to talk about it.
It's kind of like, just make it work like it worked before, you know. And I've been doing word processing. I was the original, literally the original WordPerfect user. It was my office mate, Bruce Bastian, here at BYU, who was developing what turned out to be WordPerfect as his master's thesis. I was sharing an office with him, and I used it to type out several papers my senior year. So my word processing goes back a long ways. It's kind of like, don't change this. General simple requirements, I cite this stuff to you all day long. You come out what you think are, here's a good set of requirements, and then when you start to implement, it's like, well, requirement A actually now splits into requirements A1 through A15. In order to implement A, I've got to do all this other stuff. You have, usually there's often a failure to formally manage requirements via change control. And what happens here is you get a lot of scope creep. In other words, it's kind of like, oh yeah, that's a good feature, let's throw that in there. Oh yeah, that's a good feature. Now, as you're throwing features in, then you have this whole explosion thing. So, it's going to get out of control. A lot of project failures are due to scope creep. When I'm looking at a failed project, either a troubled project as a consultant or a failed project as an expert witness, that is always an issue. What control was there over the scope? Who signed off? What was changed? Both waterfall and agile approaches have separate problems with requirements. A waterfall approach, you get this analysis paralysis, which is you spend all your time and you never finish nailing requirements. You never sort of put the stake in the ground and say, that's it, we're not doing anything else. Interestingly enough, in Pages, being late solved that for us because we missed our first ship date, but we'd already done the manual. So our CEO printed out copies of the user manual. And he literally put a copy on every developer's desk and says, if it's not in the manual, we're not doing it. And that was our feature freeze while we're trying to finish it. Agile has the advantage of heavy customer interaction up front and trending towards a solution. The problem that you get with Agile, I've seen this, imagine this is a plane here, a 2D plane, and it's your solution space, and you've got solutions of different heights representing various, the higher the solution, so to speak, the better, the more applicable it is, the more the market you cover, and so on. Problem with Agile, where you're starting off at this point and then doing incremental changes, is that you can get on a local maximum and then never get off of it. Because any improvement that might lead you, say, over here, is an immediate decline in quality. When you can take the time to do architecture up front, what you do is you try to survey as much of the solution space as possible and say, what architectural decisions will help me to maximize this. In Pages, we did this. Pages was a drag and drop desktop publishing system with the idea of interchangeable design models. A design model was the look, basically the look of the document, the headlines, paragraphs, fonts, various other elements. And the idea was you could create a document, one design model, switch to another, it would lay itself out, perfectly adhering to the design principles of the second model. Which it did. It actually worked quite well. And early days, I did something which was a great thing to do, but also the source of much pain for me. I went to Vic Spindler, a graphic designer, and he had 2 or 3 sample design models. And I said, Vic, I need the most bizarre design model that you think will be in the scope of what we're trying to do. And he created one called April, after a well-known graphic designer, April Greiman, which had things like circular headlines that the text had to flow around and so on. And what I found in my architecture and design work is that it was very easy to match the relatively plain vanilla ones. But then I tried to make the code work with April. And I was just beating my head against the wall. Now, April worked, and we shipped with the April design model. And as a result, we had a much more robust and comprehensive architecture. We could do more and more unusual things because of that. So, basic idea of requirements is to know when you're done. After Pages folded, saturated market, couldn't get funding for the web, for Windows. I got a consulting job as chief architect at ARINC at the Newport Beach, ARINC, Aeronautical Radio Incorporated. This particular division was doing the network management software for Motorola's Iridium satellites. I was brought in largely as a chief architect, which I've mentioned, but they'd had a disastrous design review as far as their use of object technology because no one there knew anything about it, which is another reason they brought me in. The VP over the division, after I interviewed, went out and bought my book, Pitfalls of Object-Oriented Development, and said, my gosh, these are all the problems we have. So I figured I'd be useful in coming in. But they were also behind schedule. Bob Millar, who was at Motorola, was literally started the same day I did. He was coming there weekly to get the project on track. The first thing he asked for is, where's your baseline for this subsystem? And the ARINC managers all sort of looked at him puzzled. He says, where are the notebooks? Where's the requirements that say, you know, what you're building? And they still didn't have anything. And he finally said, if you don't know what you're building, how will you know when you're done? And he said, I'm going to ask for this every week when I come back, and I won't be happy until you have a couple of binders sitting here on this table that describe exactly what you're building. For this next release, it was a dot release. This is a many years, multi-year project. And within 4 weeks, he got those binders. He held their feet to the fire and made them specified. This is the same place where I think I mentioned a week or two ago that I went in and asked to see the architect. Well, I asked who the chief architect was and got 5 answers, none of which were actually true, except for the one that said nobody. And asked to see the architecture document. And there was no architecture document. There were 4 design documents for 4 subsystems, and they didn't mesh up. Their interfaces didn't match, which also describes some of the problems they're having. Another problem was they had 30 people writing about 14,000 lines of code. That's way too many people to write 14,000 lines of code. That's, you know, you're down to like 500 lines of code for each person, and they're all having to communicate with each other. Work things out. Yes, you have a question? Okay. So your requirements document at this point is to give you enough of a guideline to define what you're going to build. For some of you, you've got research that you're still doing, investigation. You should try to put down, here are the areas we need to research. This is what we want to find out. You know, if we can do this, or how to do this, or whatever. There's a good podcast on software requirements. I recommend you watch. It is a good practice to define what you're not building. Not enough groups do this. But it's a good idea to say this application will not do this, will not do this, will not do this. At Pages, again, one of the things we did after we closed on venture funding, got our permanent CEO, so on and so forth, is we made a spreadsheet. It's basically we researched every desktop publishing and word processing product out there and made a spreadsheet of 600 plus features. And then for each and every feature said either this is going to be in the product, this may be in some future version of the product, or this will never be in the product. By going through that exercise, we immediately shut off whole areas that we ever had to worry about, either for the 1.0 release or for any time. You know, if we're looking at it as a post 1.0 feature, then we had to make sure we didn't exclude it. But for anything that we said we're never going to do this, we just didn't worry about it, period. So for this class, you'll want to keep your requirements lightweight, but express it in terms of explicit features. and this should be revised continually. If you go back to the 2017, fall 2017, you can see various examples of requirements documents. Again, feel free to steal one of those and use it, but make sure it actually works. So, you need to have your initial draft. Now this is where you're really going to start putting in some billable hours. Have your initial first draft requirements document on GitHub by Saturday. And then next week we will do the same thing. We will have each of you do a 5-minute walkthrough of your requirements, why you listed what you did, what you learned from the process of doing it. Let's break here, and you can take a biology break before the bell rings, and there's the rest of the bathrooms, and let's start again at 10 till.